this is the new exercise that we will be solving, patent abstract classification exercise. So let me quickly take you through the solutioning, how we are attempting this. Very similar. All that I did is I just went ahead and changed the file name. You can see pip install datasets is where we will take the datasets from Hugging Face, and this is how my dataset looks like. So you can see that every row corresponds to a text and a label. The label is basically the under what group the patent is grouped into. Very much like a document categorization, or maybe another real world use case could be how we go and categorize news stories, something very similar to that. Okay, so you look at a use case like Google News. So you've got different types of news story, and based on the different types of news story, based on the content of the news story, you're effectively trying to classify what is the so based on the different you know uh, category of the news story, you're trying to classify what is the class of that particular news story. So that's the use case. So something very similar we are trying to do. Okay. So again, we have the how many different classes we have. You can see we can use something called value counts to test that out. 1, 2, 3, 4, 5, 6, 7, 8. So this is the multi-class classification. Unlike the last use case where we had sentiment analysis, it was binary classification. This one will be multi-class classification. Okay, so multi-class means there are multiple categories that we have right now. So we are looking at something like a multi-class classification here. Okay, and we'll try to uh, identify from these categories. Okay, one more very important aspect I wanted to talk about is it's very important to ensure that you have the right quality of data. It's very important to ensure that the data quality has to be good, the data quality has to be strong. And I think if you just look at this current exercise, the kind of data that is given, the data doesn't seem to be very well organized and well balanced, because there seems to be lots of examples of human necessities, but there are very few examples of fixed constructions. And this is an important thing I wanted to clarify. So you need to have a well balanced data. So don't have like lots of examples of one category and very few examples of the other category. Okay, so we need to ensure our data is well balanced, and this way you'll be able to give curate a better quality prompt. Because remember, all this is going to be part of my few short examples, right? All this will be part of my few short examples, what I will use to fine tune my prompt. Okay, so it is like saying that you're showing the LLM model more examples of human necessities category, but very few examples of fixed construction category. Okay, you're showing the language model more examples of the physics category, but you're showing it very less examples of the fixed constructions category, and that is a problem. So when we talk about fine tuning, when we talk about fine tuning the language model, or fine tuning the prompt in this case, right, through a few short examples, uh, maybe the LLM will not learn human necessities, fixed constructions very well, but it will learn human necessities very well, because there are lots of examples that you're giving for that. So data curation is a very, very important part, goes without saying. It is true in traditional machine learning, and it's so much true even in generative AI based tasks also. It's very important to curate the data, fine tune the data properly. So all these are very risks we have even today. Okay. Okay, moving on. What we have done is, again, we have split our data into few short and gold examples. So, and you can see here in this exercise, I'm actually trying out different types of prompting techniques. As I told you, this is something that needs to be tried out. We have to try out different types of prompting techniques and see which one works. So first, we try out a zero-shot prompting technique. You can see this is the system message, and we are very explicitly stating that what are the different categories that you have to group your patent abstract into. So depending on the patent text, these are the total 8 different categories. There are 8, right? 1, 2, 3, 4, 5, 6, 7, 8. 8 different categories we have to group it into. Okay, I'll give you a slightly better suggestion. Instead of directly listing out the text, because each of these categories are fixed, right? Another very good practice that we use for classification problems is we try to label encode these texts. We don't explicitly say that, okay, group as part of this category, group as part of that category. We don't do that. We don't explicitly state the text of the category. But another very real world way how we do it is we just encode it with a label. We encode it with some kind of a label, and we say, okay, let's say human necessities is part of label 0. This is label 1, 2, 3, 4, 5, 6, 7, 8, 7. So instead of saying human necessities, we will call it 0. Instead of saying physics, we will call it 1. Just like how we were doing the sentiment analysis. Remember, we had sentiment 0 and sentiment 1. 0 means negative, 1 is positive. So something very similar we will do here also. So we will label encode these outputs. What is the benefit? The benefit will be to some extent with respect to accuracy, because remember, they are language models, and the more text you have, on one hand, there's a token cost that you're incurring. So if you ask the language model to generate that entire token, there's a higher costing. No, we don't have to print out. Like for example, here, mechanical engineering, lighting, heating, weapons, and blasting. We don't have to print out all these words, right? We're already adding close to approximately 6 to 7 tokens here, but we don't need that. If we can replace this entire thing with a single label, let's say label 6. I just want the language model to print 6. That's it. And 6 corresponds to this. We can maintain a separate dictionary, in Python, where we can say, okay, 6 corresponds to this particular label. And then we can separately output it later. But we want the LLM to only print 6. Okay, so we can label encode. This is again a best practice that we use. So for the current exercise, the solution that I've shared, I just stuck to the normal approach, where I'm asking the language model to list them into these corresponding categories. You can see. So these are the corresponding categories that we are having. And then we try out some other variants of prompt. This is one more very detailed prompting that we are trying out. You can see. Again, each abstract can belong to only one of the following categories. And the only additional thing we are doing here is we are giving a more detailed description of each category. And why is it important? Because remember that yes, the language model has few shot capabilities. We are not denying that. We are absolutely clear with the fact that yes, all these language models, they have few shot capabilities. They have an inherent understanding of things. But you are still adding some more detail to it to help it, to guide it, that what is human necessities, what is physics, what is electricity, what is general tagging, because you are the domain expert, right? This is your field of work. The LLM is trained on generic data, yes, but that's an assumption that you're making. You are trying to ensure that it is able to correctly classify, and it is able to correctly classify the text into the corresponding categories. So that is one of the things that you're doing here. Okay, so the more detail you add, the better the quality of the prompts. You can see all that I'm trying to do here is I'm just trying to try out different system messages. This is system message variant 1, variant 2, variant 3. You can see the solution file also, variant 4. Okay, and this is something called COT with thinking exposed. Okay, and what we do here is right at the end we say, present a detailed description of your thinking process. It's a chain of thought with thinking. So this is especially very useful, especially when the LLM makes some mistakes. When the language model makes some mistakes, you want to go back and see at what mistakes are made and why those mistakes are made. So this is with thinking exposed. That's what we are actually tracking here. Okay, and if you scroll down, this is an example of a few shot prompt. Same thing, we have the detailed system message, and this is how we are curating the few shot prompt, exactly like we did for the sentiment analysis use case. And you can see here I'm taking 4 examples, and you can vary that. I told you already, especially very important for this exercise, because this exercise there are 8 different unique categories, right? And because there are 8 different unique categories, what will happen if you take only 4 few shot examples? Maybe there are some categories that might get missed out. Okay, there are some categories that will get missed out. So if you take only sample of 4, remember there was only one example of constructions. There was only one example of some of the other categories. If you take only few short examples of 4 samples, if you take in few short, some of those categories can completely get missed out. And that is the problem. So this is again goes to show that why it is important to iterate and try out different things. Okay, so take a higher sample size here, because there are 8 unique categories. So at least the sample should be at least 8. I'm saying at least. And more than that, maybe you can take 16 or 32 in this case. And you have to also ensure that there is an equal balance of the different classes in that sample. Okay, so there should be equal number of human necessities, there should be equal number of fixed construction, equal number of physics. Ideally, we should have a very well balanced data set to start with, because otherwise what will happen is the LLM will end up becoming biased. So if you show it more examples of fixed construction and less examples of physics, then it will learn the fixed construction part well, but it may not learn the physics part well, because it has not seen enough examples of how it is done generally. Okay, so this is very important, and you can already see the few short prompt is a very big prompt. Okay, and this is again part of your system message and few shot. I think now everyone's getting a slightly better understanding, in terms of what is this system parameters, what is it that you're actually developing. So what you're developing is this. You're developing the system message, you're crafting a detailed system message, you're curating your data properly, you're crafting a good amount of few short examples, well balanced examples, and at the end of it all, you're crafting a high quality prompt along with high quality prompt parameters. And once you have that, now we will test it out. We will test out that prompt against the ground truth data, and we are getting 37.5% accuracy. This is not surprising because remember I told you that this is not a well balanced sample I've taken. So the data itself was flawed, and also the few shot prompt I've taken is flawed because in the few shot I've only taken, if you remember, a sample size of 4, which is not even covering all the categories. Okay, so these are very real problems that I wanted to highlight in this particular exercise. Okay, and then rest of it at the bottom, I'm actually going and correcting some of the things you can see. Okay, so we are just trying out some more variations right now. So here I've tried a sample size of 20. The sample size of 20, just having a higher sample size itself is not going to solve the problem because remember, my inherent data is still imbalanced. You'll have to correct that imbalance first. And maybe here also it's randomly taken. When I say sample 20 means out of the whole data, 20 rows are randomly taken. So you have no control on what classes are getting selected, what classes are not getting selected. Okay, so this is also very, very important. And in this particular exercise, the classification report will be very, very crucial for you. So although we are getting 34.75% accuracy, this is the overall accuracy that we are getting. But what will be particularly interesting to see here will be the classification report. Okay, so but yeah, I mean, if you try to run this prompt, it will take a long time because I think that few short prompt easily will cross upwards of 10,000 tokens. It will be a long prompt. Okay, it will take more time in this case, but it will be very interesting to see the confusion matrix and the classification report, and you will actually get to see the class-wise accuracies, the class-wise F1 scores. Okay, how every class is performing, not just an overall 37.5% accuracy, but each individual class, how is it performing? And you will see very clearly that some of those classes, like if you remember fixed construction, like we had only one example of that, right? So whichever classes had only few number of examples and which are not represented well in the whole data, so they perform very poorly. So they perform very poorly, and maybe for those classes, the model will perform very poorly. Okay, so this is a very, very helpful way. The classification report is a very helpful way where developers can work on their solutions and they can build better applications which are more representative of all the classes.